All right, so this talk is called something Hypermedia APIs. It's about a journey I took when I was learning how to do REST APIs, and then realized I ran into some roadblocks. And it turned out that there was a thing out there called Hypermedia. So this is an exploration of this. A lot of this is extremely new too. There isn't too many frameworks out there that exist for this kind of stuff. So there's still a lot of exploration, a lot of competing tech trying to be the Hypermedia API whatever tech. So it's all very exploratory here, but I'm hoping that I can inspire you to consider this when you're building your web APIs, or even being a client consuming web APIs and seeing that, hey, this sucks, there's got to be a change. So you will be the catalyst. My name is Helior Colorado. You can follow me on Helior on Twitter and GitHub and Drupal and all those things out there. Yeah, jumping straight into it, I want to embed an idea in your head. First off, let's talk about why the web has been such a successful platform throughout the decades. And what I mean by as a platform, as opposed to building an app on an iOS platform, or for a Microsoft Windows platform itself. We build apps on top of the web because it is a platform of technology that exists. And it is the largest platform in the world that has scaled, and it has proven that it scales. The idea of the web has promoted feature and backward compatibility, and we see that through websites that we update versus the clients that we update, like our browsers. We don't see things breaking all of a sudden, or at least for the most part they don't. But the idea is that it is extremely sustainable, and it is largely decoupled. We don't just have a centralized place for the web, it's distributed all over the place, and yet it still is a very strong foundation, not something that's very brittle. So that is an idea for you to think about why the web is so successful. But although these are minor points to it, it's kind of hard to identify what aspects and what facets about the web make it successful. And so hopefully through intuition or through using a client, you start feeling or getting a feel of why the web is successful, even though we can't really pinpoint it by name. So early on this millennia, we got into the idea of web services, where instead of the web itself, or a browser going out to a website and then you browse a website, that's it. We coined the idea, and I forget the slides. There's supposed to be lines in between these, but I guess the little arrows are missing. But the idea is that other websites are consuming data from services out there. So websites that are dedicated to synchronizing the time or dealing certification for SSL. Security, whatnot, things that do calculations on the web for you, such as like Wolfram Alpha, or even doing some sort of a finance service. Like all these websites, they specialize on a certain thing, and they expose that to the web so other websites can consume that. This has been a trend that's been going on for the last 10 years or so, and these are, in a sense, what web services are. But in 2001 came along a guy named Roy Fielding, who wrote a dissertation called The Architectural Styles and the Design of Network-Based Software Architectures. And basically what he's talking about is how to build successfully a system that is on a network, fundamentally works on a network. What are all the key elements that we need to implement in order to make this a thing, a platform, or something that's sustainable? And within this dissertation, he talked about an idea called REST, in which we probably have already heard of. REST stands for Representational State Transfer. But oftentimes when we think about REST, we don't put that phrase together with what we actually see, because all we think is, oh, there's an API that has a documentation that says if I go to this URL, I should get stuff. And so the concept of what it's called isn't really mapped to what it actually does. A definition for this REST thing is it's an architectural style that's consisting of coordinated set of constraints, and that's an important part, which is applied to components and connectors and data elements, and we'll talk about what each one of those are on the web, within a distributed hypermedia system. So that was the idea that was founded within this dissertation by Roy Fielding. And by the way, Roy Fielding is a very, very angry man, because he decided, or he determined what these things are, but as people were implementing it, they're just kind of picking and choosing what parts they want to implement, and he has to explain himself through his blog. No, you're doing it wrong. This is what I meant by this part in the dissertation. So, he gets up a little steam. He has a bit of fire in him. But the idea here, that when he talks about REST and defining what this thing is its constraints. REST is defined by its constraints. Otherwise, REST would be this thing that's going willy-nilly, but there's very strict rules in here that kind of define what you can do and what you can't do, and it builds a sort of logic set in which you can work with. First off, there's a separation of concerns between the server and the client, right? A server being something that's providing these payloads, these resources, and a client being something that's consuming it and then doing something with it and possibly like presenting it to you, whatever the case might be. There's a separation there in which there should not be any assumed information about these. There's no tight coupled between these two components. They are completely separate. And that allows for having n number of clients approaching n number of servers. They should be interoperable. The other idea here is that REST is stateless, meaning that it doesn't assume any kind of predetermined state like authentication, or it has some sort of a memory of what had happened in previous states. It's basically, it does everything all in one request, back and forth, and it assumes nothing prior, nothing in the future. So there's no concept of like a history that should be persisted. So everything you need should be within the request and within the actual returned JSON blob or whatever it might be. Also the idea that REST is cacheable, and this is by nature of using HTTP because we're defining when a certain piece of content is expired because we're sending expiration headers. The concept of caching is possible within the REST, but that's an implementation detail that's handled on the client. But it's possible because there's rules within this. Also, the interface between different components, we don't have to, if I'm talking to machine A to machine B, have one sort of interface, and then machine B to machine C have a different set of rules to communicate. They are all uniform. They are all the same language, so we're speaking the same language mechanism for transporting data back and forth. So that's an important concept there. REST in itself is a layered system, and this is something that you probably have experienced already with, with websites. You request, say, google.com, and you might not necessarily have a direct connection to google.com because there might be like layers in between, like a caching layer or like a load balancer. But the idea is you can throw in as many layers as you need to. The functionality of it doesn't break. And again, there's no like lockdown concept with the client, any kind of predetermined knowledge that there is any layers in between. It doesn't care, it doesn't need to know. It's that loose coupling again. But it's a layered system. There is possibility to have layers in between. And a bunch of other constraints that are defined within REST itself. And if you really want to, you can read up on it. It's all there. But I'll define some other things too. I mentioned resources without really saying what it is. A resource you can think of and say Drupal parlance would be like an article or a comment or a user. This is like conceptually a thing that exists out there. And as far as resources on the web go, you could just say it's a primitive data object. And it's a simple element that is a standalone thing in itself. So using the word thing as abstract as possible is probably the best way to define what a resource is. And then we have URIs, in which we define where can we identify these resources. And so URIs themselves is a technology spec, and it stands for Uniform Resource Identifier. And in essence, it's just a string of characters used to identify a name of a resource. So resources exist out there as a thing, and then URIs say where to actually find it. So just as a reminder, though, REST is an architectural style, not necessarily some sort of ISO standard that we have to adhere to. And it's because of that that people, organizations would implement their own kind of flavor of REST. And there's different styles of it, I guess. There's different tolerance levels of how a REST API should work according to them. So because it's a style, so they choose how to implement that style. There's this guy named Leonard Richardson, who was an author of RESTful Web APIs, RESTful Web Services, and a bunch of other fine books. And he blogs a lot about this stuff. He's pretty passionate about how REST should work. And he talks about this thing that's pretty interesting. We call it the maturity model, in which he describes 3 technologies, so HTML, HTTP, and URIs. And he says that RESTful services out there can be kind of determined how mature they are based on how well they understand these technologies and if they use them at all. And so he kind of describes or critiques certain API web services as in the following. So first off, I'll define what HTTP is. It stands for Hypertext Transfer Protocol. You've probably seen it. It defines how messages are formatted and transmitted. So that's part of its spec itself. And also what actions web servers and browsers should respond based on the various commands that it's receiving or sending. Down at the very bottom, you have an example of what actual request looks like. using the method get, which means I'm just going to view something. And I'm using the URI events 2013, etc., etc., etc. And at the very end, I'm specifying, hey, I'm using the HTTP spec version 1.1. So, implementers out there should be using that specification. That URI that I sent, you should be looking that up on the host of helior.info. And by the way, I accept text/HTML as the media type. So that is what, as a client, I would understand, and I expect that you should send me back. All of these things are defined within the HTTP spec. But in the rich to maturity model, a level 0 web service API is one that doesn't really understand HTTP. It only uses a single URI and uses HTTP as just a transfer mechanism. So it's not using verbs like get or post or put or anything like that. It's just saying send your stuff over to this one URL, and even URIs don't exist. We could have just a single endpoint, and Drupal actually has this too, like the xml.rpc file, right? You're basically sending a blob of XML or whatever, and to that URI, which is not really URI, it's just a single endpoint, and says do stuff. But the idea here is that it's a complete black box. We're posting data, so we can't cache it. So we're totally not using HTTP there. We don't really define URIs at all because there is no URI. It's basically just a single endpoint, the xml.rpc.php, and the data itself. It's a black box. You don't know what's in it. It's just XML, and there's no semantics in XML themselves. So you're basically just sending post data, and it could be anything. You can read a file using this post data, or you can say, I want you to execute this other thing. It could be an unsafe command. And with HTTP spec, you're supposed to be using get as a safe command, not as something that could potentially be destructive, like deleting a file or deleting a resource or adding a resource or whatever. So there's certain APIs, especially at the beginning, where they work only on SOAP or XML, and they basically didn't use any of these technologies, only HTTP as a transfer mechanism. Other APIs out there this is, I guess, the next level over, where they started using more URIs, so it's not just posting to a single endpoint, but now you have URLs like user21 delete, right? When you request that URI, it's going to delete that resource. So that seems pretty intuitive, and it's using URIs, which is great. You have many different URI endpoints, but you're still not using HTTP correctly because you're getting, which is a safe request, user21 delete, which is actually an unsafe operation, right? So now, like, you're still not using the technology right because there's certain implied mechanism when you use the get method in HTTP.
The services module and Drupal stuff at this level, kind of for the most part.
Drupal itself comes with XML-RPC, which is the level 0.
Right.
The service module adds in the layer where you can have the concept of resources, and it exposes these URIs.
Right.
And it will support. It will support get requests or delete or put. So
okay.
it totally can. But at the same time, the service module also supports using XML-RPC within the endpoints. So it could be exactly like this.
It's a hybrid. Okay.
Yeah, exactly. So you choose to implement it whatever way, but that's, yeah. And actually a lot of APIs out there, or at least they used to be, like within the last few years, worked just like this. I know famously the Twitter API worked just like this, and they change it and they do all kinds of stuff. And we'll talk a little bit about versioning too, whenever a server changes its APIs, what happens to all of its clients. But yeah, level 1, it's only using URIs, but still doesn't get HTTP technology yet. And here's an example of a request and then the data object that you get back, just kind of have a visual of what this is. So again, I'm getting the events, I guess, listing page, that's the URI, using HTTP 1.1 as a technology. This is the host. I'm accepting JSON, and the media type is application/JSON. And the server sends me back this. It's just a blob of events. And it's actually a list where I have multiple, so it's an event listing page where I'm listing out the ID, the name, and the date of the event. And I have 3 items in there. That is my resource in itself. Just as a visual. When we get into the maturity level 2, we get into APIs, which are getting a lot better. They're using HTTP as they're supposed to, so they're using the actual appropriate method, and they're still using the URIs. So now we can have stuff like user21, and you could get that if you want to, and if you get that, you're going to get the JSON blob or whatever, resource representation for that user21. Or if you send a delete method to user21, appropriately it would delete that. Right? So now we're using HTTP and we're using URIs. And that's how every API works today. And that's pretty much at the pinnacle. And yeah, here's an example of that. I should mention also, I just added in this presentation this morning, and so I'm like, as I'm looking at these slides, I'm reminding myself what my point was. So it's going to be a little slow in that sense. I'm going to have to figure out what I'm going to say as the slides come in. So yeah, this slide was thrown in there as an example of what an appropriate request could be using HTTP. So delete event 52, and that's it. The request, or at least the response, shouldn't be anything in particular. Probably just saying no content, which is HTTP's method of saying everything went okay. Kind of like the Unix command. If 1 isn't returned, if it's just 0, then I mean everything was just fine. So same idea here. So anyway, moving into what level 3 is, I mentioned in the earlier slide that HTML was at the top because HTML is something that we all understand. But really, it's hypermedia itself. And I'll talk about what hypermedia is. But the idea here is that the resources, that JSON blob that I showed you earlier, it actually describes what it's capable of doing and how it communicates with other endpoints, right? Previously, you would just get a blob that says, here's my user ID with the username, and here's a description, and maybe a URL to like an image or whatever, or like a biopic. But within Hypermedia, if we have that enabled, the JSON itself would describe so much more than just the element or the resource itself. So Hypermedia, it applies to various different media types, thinking of images, thinking of just text or whatever, but it applies to all those different media types. And it's the logical extension of hypertext, as you're familiar with HTML, which are documents. So a reminder what hypertext is. It's documents that contain reference to other documents. There's a certain linkage involved. So we have text, but then when we have hypertext, we have links that go in between. And so now you can start navigating between different documents. Hypermedia applies that to general media types. So think about that concept. And Hypermedia APIs, they serve responses as hypermedia that manages the application state, right? And that's an important concept. It is REST. It is originally what REST was defined as when you look back at Roy Fielding's dissertation. So think about manage application state. Now I mentioned earlier when we think of the word REST, representational state transfer, that doesn't really map well to what we are used to with resource-driven API documentation, right? You don't see the connection between the two, but when you think of that, a REST or a Hypermedia API is supposed to manage the application state, then that term actually means something. Here's a quote from Tim Berners-Lee in a book he wrote, Weaving the Web, where he's talking about how he created www. In an extreme view, the world can be seen as only connections and nothing else. We think of a dictionary as the repository of meaning, but it defines words only in terms of other words. I like the idea that a piece of information is really defined only by what it's related to and how it's related. And think of that with resources themselves. A resource item is probably just a standalone thing, but if you can see what that resource is connected to, or what objects or actions are appropriate to that resource, then it kind of defines in different perspectives what that resource can be, and that will mirror its effectiveness within its client's API. So let's talk a bit about what you already know, because this kind of puts the bridge between something that we're very familiar with to the ideas that I guess I'm trying to pitch over here with Hypermedia API. So think of in a browser, right? You want to send data to a server, right? And on a browser, on a HTML page, you're presented a form, and it has labels. So you have the name, email address, the subject title, and then a body for the content, and you have a button to actually send the data. You don't have to guess what data format you need to send it to, because the form is actually forming that already, right? You don't need to look up an API documentation site that says this endpoint that accepts this post request requires a name field, it requires an email address field. It's all baked into this representation, right? So this is how we send data, and we take this for granted. All these things in between, we take them for granted. Getting to your orders page, navigating to your orders page, on the browser, you just kind of click through the home page and go and click on your accounts link, and then you can click on the your orders. You're able to click from one place to another to get to your orders, but you might not necessarily know what the URL of your orders is, right? You might assume, okay, maybe it's your/orders or something like that, but that's probably not the case. And probably it doesn't matter. You don't need to know what the URI is. You just need to know how to get there. But through clicking through different links, you find it. So there's a certain idea of navigating or browsing or just traversing through links. That is possible in your browser. How about accessing relevant data? This is a screenshot of a GitHub project. And within the context of GitHub project, what can you do? Think of the actions that you can possibly do. And you have them listed right there. You can view the issues that are pertaining to this GitHub project. You can see the pull requests that are pertaining to this GitHub project. You can link into the admin section and delete this GitHub project if you wanted to. But the idea here is that you know what you can do with this particular resource, right? These are the actions that are given to you. They are presented to you. So that's something that exists on the browser today. Also, what happens when you upgrade a website? Do you have to do all kinds of hurdles when you move from like HTML4 to HTML5? Do you have to do any kind of custom stuff on the client? You probably don't, right? You just change the input type. Like say for instance, this is a HTML5 widget for like the date field. So if the browser is implementing like a little calendar that pops down, that could have easily been rendered on IE6. It's probably not going to show like the actual calendar, but it's still a text field. So things don't necessarily break. So there's a concept here of feature compatibility and backwards compatibility that's baked into browsers, and your code stays the same, or your code doesn't have to do anything fancy with it. So again, these are the kind of concepts that we take for granted. I wanted to map this to how web APIs work. And the idea here is that, and I'll read this up, transitioning from REST to Hypermedia is like moving the focus away from resources and into the action you want to take place. So instead of being resource driven, where you're just giving, bam, here's a comment and here's all the data that's involved with it, I'm actually giving you the comment and links to the author. I'm giving you the links to the post that it originated from, right? I'm giving context to the comment so it actually has life and has like some sort of operations that revolve around it. So you have context as to whether you can delete it, or you can view it, or do whatever the case, whatever you can do with the comment or whatever kind of resource. And that's the change with Hypermedia and REST. It's from going resource-driven to being action-driven. So I'll talk a little bit about what out-of-band information is. A strict definition here, as I wrote it, is implied processing instructions that are not included within the response message of an API server, when they should be, right? You have communication, implied communication between the server and the client, or the other way around, but it's not part of the request itself. And I mentioned earlier that REST should be stateless, right? Everything that you need to do a certain operation, whether you need authentication or whatever, it should all be packaged within the request, or it should be packaged within the response that comes back. And when I first presented this, there was a video that I had along with it that kind of helped describe this. It was a clip from Office Space.
Really? I have 15 pieces on.
Well, okay, 15 is the minimum. Okay.
Okay.
Now, you know, it's up to you whether or not you want to just do the bare minimum, or, well, like Brian, for example, has 37 pieces of flair on today. Okay, a terrific smile.
Okay, so you want me to wear more?
Look, Joanna,
Yeah.
people can get a cheeseburger anywhere. Okay, they come to tchotchkes for the atmosphere and the attitude. Okay, that's what the flair is about. It's about fun.
Yeah. Okay, so more than, yeah?
Look, we want you to express yourself, okay? Now, if you feel that the bare minimum is enough, then okay, but some people choose to wear more, and we encourage that, okay?
So the point here is that Stan is trying to communicate something to Jennifer Aniston's character, forget her name, but he's not saying it out loud. He's assuming that she's going to get what he's trying to say. And how's the server not doing this with the client? Doesn't the server kind of expect the client to know that there's a web API, web page, so you should be able to look that up? And you should be able to figure out how to construct the URLs. If I give you a comment ID, you should know exactly how to construct the comment ID. The server assumes this information because it's not giving you that link, right? That is out-of-band communication. And this is broken. This is a failure because that requires someone to go in and interpret the information and then do something with the client and hard code the client. So now you don't have loose coupling anymore. You have a tight coupling between what the client is expecting and what the server state currently is. And when the server itself upgrades to the new version of the API, it's totally going to break all the assumptions that it's bestowed upon you with this out-of-band information. Let me switch over. So yeah, that's what out-of-band information is. So what else in terms of like within web APIs? What is out-of-band information? And one example is the context of availability. And the word affordances is thrown around when we're describing this. Okay, this is managing application state. The idea here is that imagine each one of these circles as being a state in which you're doing a request and you get a response back. So you go to some sort of URL that takes you to a home page. Now this is going to be some sort of an e-commerce site. You can imagine this as being from a web page or from a mobile phone or from whatever kind of interface you want. The idea is that you have a client and a server relationship. The idea here is that the server is going to be providing, affordances of what action you can take next based on where you currently are. So when you are on the home page or you receive the data from the home page, think of like a product listing page, right? You have links of all the different products and maybe you have like the titles and maybe little thumbnails of each one of the items so you can represent that on your client like on the phone. But the point is that you have links to get to the product when you choose it. So the affordance that's allowed when you get to the list of products is that you can view these other individual products. So that is what's available to you. That's the only action that your client can provide. Therefore, your client should not try to create buttons that do other things that are not within the context. So now the client UI is dependent on what affordances the server is providing to generate the UI. It's an important concept. So from product 2, what options do you have available? You can add product 2 to the cart, right? If you can add an item to the cart, you probably want your client to produce some sort of an icon for it or a button that does that. Your client should never assume that it's going to, at this point I'm going to add an add to cart button. It's going to be looking at the server's affordances to decide, hey, there's something that's related to add to cart and here's a link to it. That means I have the option available to me from this state. And I don't even have to know what the link is or wherever the URI is because the response itself, the server, is providing the link to that for me. All I have to do is grab this stuff and render it, and the client doesn't have to assume what the URI is. It doesn't have to assume whether or not to display the icon or not because that affordance was available to it. So once you add an item to the cart, now you have a cart to view, right? A client would never display a view cart if you don't have any items in the cart. It's irrelevant, right? So again, once you have an item within the cart, the server can provide the link to viewing the cart because now you actually have one. So we have an idea of context here and what's available. And from the view cart, once you're actually viewing the cart, you have some options like removing the item from the cart, or you could also do something like change the quantity of the item, whatever's in there. So these would be within the view cart response options or links that are available for you and for your client to implement as like a user interface button or whatever. And from the state of view cart, you can also go to checkout. So think about the process from going from home to checkout doesn't make sense unless you have certain context of products in your cart, right? Your server can dictate whether those options are available for your client to represent, not the client trying to figure out what that workflow is and represent those buttons when it thinks it's appropriate, right? Because you already have business logic happening on the server. Your client shouldn't have to repeat those business logic because, how can you possibly reproduce clients for every different version? Or even like, for instance, you have the Twitter server, right? A Twitter API server, and how many different clients out there exist, right? Imagine if each one of those clients had to reproduce the business logic that goes into Twitter. Every different client, it's not efficient. So having a client that bases every kind of interface that it has or any action that it does based on the affordances that is provided from the server is a huge win. And again, from each one of these states, you probably have a link that goes back home if you wanted to, because the context of the home is always available, right? So that's where that button would come from. So yeah, application state. So I guess here's a proper definition of that. Affordance is a current representation of links and controls that reflect the context of a given state, such that the user obtains choices and can select actions. And that's the really powerful part, is that a client could then choose what options are available to it, as opposed to like trying to make it up with the assumption that, hey, the API says that I can do this, or there's an endpoint, so I'm always going to have a button that takes me to whatever the case might be. So it's driven by the actions or the business logic that is represented by the server. So what else is available? How about how to actually process the content that you're getting back, right? So this kind of goes into the idea of media types themselves. I mentioned that JSON doesn't have semantics applied to it, XML doesn't have semantics applied to it. It's just a serialization format. Right? Here's some examples of different media types that exist out there. Text HTML, text CSS. A lot of these you're very, very familiar with. Each one of these has a specification, an RFC, that states how it's supposed to be implemented, or at least how it's supposed to be interpreted. And the thing that's cool about this is that they are extendable. Think of the text XML media format, how that has been extended to be something like RSS XML, right? We added semantics on top of XML, so then we could actually do very interesting things with it. How we define it, or at least how we label it, is application/RSS plus XML. So that's saying that, hey, if you don't understand what this media type is, at least you can fall back to application/XML, because that's what it really is. But if you do understand the semantics that are added to it, go to town and do stuff with it. Also, you can have, like, if your media type is not defined with an actual spec, if you're, like, say, a company that's trying to do their own kind of media type, you can put a prefix of VND for vendor if you wanted to. But the idea is that there is a format, a structure of saying that here is my media type, server or client. If you understand it, do something with it and give me back some semantics. But if you don't, then it's okay. I can settle with just XML or just whatever kind of text. This pertains to the idea of versioning, right? You can now, or your client and your server can tolerate a certain amount of versioning, because really there is a graceful way of handling the change. And really that's all versioning is, just managing change between your implementations. So yeah, something media types. I guess here's where I talk a little more about what media types are and the semantics within HTML, or within XML or JSON. They don't currently exist, and that's a problem. And there's stuff out there, or people out there, who are trying to create specs for JSON APIs. And you might have heard of HAL, which is something that's being used right now in Drupal 8, which basically is like it's like hypertext application language, something like that, where it's still JSON and it's still XML, but it adds in certain properties to the resource that says, here is the link to myself. So here's a canonical URL if you ever needed a resource back to me. Here is a link to all the different related items, so you don't have to derive that value yourself, right? And so it provides everything for you, and it also provides like a property that says, this link, the rel link, this is a language, or this is a checkout button, or this is a whatever you call it. But it's putting context within the link itself. And it's not just thrown around randomly. It has a spec saying like where clients could find these properties and what to do when you have a list or whatever the case might be. So spec writing is difficult, and you have to think about every possible use case out there. But the idea here is that, hey, if I'm serving up, or say for instance a client is requesting JSON API or JSON LD, I think, which is another media type that tries to put semantics on top of JSON. If you don't understand that, then fall back to using just regular JSON, and I can get by with that. That's fine. But yeah, there is power implied with media types themselves, and right now it's just kind of rough whether which ones we could actually use, because they're not structured, they're not defined officially yet. So we're still in flux there. But the idea of building new semantics on top of nothing, it might seem like a very weak idea, but here's an example which it actually flourished into something very, very real. So I'll read this out. This is a required functionality for X Mosaic. We have this working, and we'll at least be using it internally. I'm certainly open to suggestions as to how this should be handled within HTML. If you have a better idea than what I'm presenting now, please let me know. I know this is a hazy WRT image format, but I don't see an alternative than just to say, let the browser do what it can and wait for a perfect solution to come out, to come along. MIME someday maybe. This was Mark Anderson talking about the image tag. The image tag was just an internally used semantic thing, and his idea was, we'll throw it out there. If the client knows what it is, great, render it or do something with it. And if you don't, then that's fine, just skip it. Very simple idea, and it caught wind. And now browsers are implementing image tags. Just like if we added in semantics to JSON or XML, then, hey, everybody wins once we start implementing that. And there is a clear path as to transitioning from just REST APIs to actual Hypermedia APIs. You just kind of, move on up into it. And finally, The last term I'll describe is HATEOAS, which is just an abbreviation for everything I've talked about. Hypermedia as the engine of application state. So the big contrast here being that we aren't just having resources that are exposed out into the web, but rather we have our workflow and our business logic exposed to the web, our actions that are available for whatever resource you're currently at, and then your clients could then implement its UI or controls that it's providing based on the controls that you provide from the server itself. And the idea here is that the clients should program against the media type because those are defined specifications about how something should be rendered, not fixed resources, because resources can change. URIs can change, but media types are an abstract idea in which you can implement and they'll stay forever. You should describe your APIs through new existing media types, not by just randomly throwing JSON blob and saying, okay, here's my new API, check it out, and of course you need some documentation, so go to that website. It should be defined by existing media types, or just create some new ones, but the idea that you're using actual media types. And define the relationship, or I'll just read that, and or define relation names or markup that extends standard media types. An example of that, so now we're talking about adding semantics to the markup or whatever itself. You've seen stuff like HyperCard or micro formats, right? We're adding in some properties to regular HTML documents, right? So we're just adding semantics to that, and it's described through that itself. So that's an idea of it. And don't define fixed resources names, fixed resource names or hierarchies. They will exist, but they will not persist. They will not live forever. Servers should instruct the clients to construct URIs within the link relationships or the link relations themselves. It shouldn't expect you to know that if I give you a client ID, then you should be able to know exactly what URI you're going to construct. You should just provide that link for it, for the client. State transitions must be driven by the client selection of server-provided choices or affordances. I feel like I've been saying that over and over again, where the client is implementing only what the server provides as resources that are available or affordances that are available to that particular resource. Here's one last quote from a guy named Steve Klabnik, who's designing a hypermedia format called JSON API. Hypermedia promotes scalability. It allows resilience towards future changes and promotes decoupling and encapsulation with all the benefits that those things bring. So if you have a background in programming, you understand that decoupling and encapsulation are a thing that really save your butt once you come to a certain point of scale. These rules or these patterns exist for a reason, and Hypermedia actually promotes that at the level of the web. So when we think about why the web is so successful, it's not because of just any arbitrary thing. It's because it's extending the web just like a program could extend itself by using encapsulation or decoupling itself. There are components that group together as a composition, not necessarily just one blob of things or whatever the case might be. So the idea here is that the goal of Hypermedia is for all clients to behave like web browsers. Not necessarily be web browsers, but take the idea that what web browsers are doing with the web and apply that to your clients themselves. The purpose being that you don't have to keep re-implementing your clients over and over and over again for every different API resource or even every different version of that same API resource. It should be a lot more resilience. And although we're thinking, okay, so how the heck is a client going to know or be able to handle change in that idea? Well, clients can do it, or I should say web browsers can do it, and they have been doing it. So just think about how are they doing it? What parts are they abstracting out? What assumptions are they not making in order to have a better tolerance for change? So yeah, that's my pitch out there. So thank you.